As I mentioned yesterday, the next couple of reactions are a little on the challenging side for students at first, but these are very important because these next two reactions are how Mother Nature makes carbohydrates, and the next two after that is how your body breaks them down. So, I don't know about you, but I'm glad she makes carbohydrates. If she didn't, we wouldn't have trees or plants, we wouldn't have oxygen on our planet, and we wouldn't have the good things in life like potato chips, french fries, the good stuff. But anyways, let's get into this. And let's look at the first one. Now, one of the things I'll be doing this chapter with aldehydes and ketones is when I write the general formula like that, when R prime is hydrogen, this is an aldehyde. When R prime is carbons, it's a ketone. So when these are both carbons, ketone, carbons, hydrogen, aldehyde, and they both undergo the same reaction. Next, we'll react it with an alcohol, carbons with a hydroxy group, and H plus means you use an acid catalyst, something like sulfuric acid. There are other acids which I won't teach you about, like toluene sulfonic acid, methane sulfonic acid, and generally in organic chemistry and chemistry in general. When we're going to use any acid that can work, you just put H plus. Now, what happens is, remember, you have a 1 bond and a sigma bond between the carbon and oxygen. And this is similar to addition of a acid, HX, or water to a double bond, except here the H will always go to the oxygen, and the OR will go to the carbonyl carbon. Again, carbonyl group, carbon, double bond to oxygen. And the carbon of that carbon-oxygen double bond is called the carbonyl carbon. And I'll use that terminology a lot in the next couple of reactions. So, this attacks the carbonyl carbon because I showed you before, nucleophile attack happens there. And what you get, first of all, do you break carbon-carbon single bonds? No. So it's ever attached, and keep your eye on the carbonyl carbon, because that's where all the fun happens. What's ever attached there is still attached. You break the pi bond, the oxygen gets a hydrogen, so it becomes a hydroxyl group. The OR bonds to the carbonyl carbon, what was the carbonyl carbon. Now, these molecules, or functional groups really, have names. I will not require you, and the ACS doesn't either, for you to learn it, but I'm going to use them because you might hear these in your other classes. And when you start with an aldehyde, when R prime is H, this is called a hemiacetal. When R prime is alkyl, you start with a ketone, it's called a hemiketal. And yes, IUPAC has nomenclature rules for this, but I will not ask you to learn those. Wow, you're getting a lot of this. Now, one other thing, because the Supreme Court outlawed cruel and unusual punishment, at least up to now, to students, on this reaction and the next three, I will never, ever on my test put a synthesis problem. This is cruel and unusual punishment. But I will put the following, or could put. And the question would be, what's the organic product or product? Before I do that, am I invisible now? White on white on white? Never mind. All right, let's get back to organic chemistry. It seems to work better with you people. And let's look at this. What's different? What functional group are you dealing with? We look here, what's different? Oxygen, double bond to carbon, carbonyl. Notice you have two carbon groups R prime, R double prime, they happen to be the same, so this is a ketone. And I can call this R prime, R double prime, or you can reverse it, doesn't matter which is which. And next, I look at what am I reacting with? What's, an oxygen with a hydrogen on a carbon, alcohol. What's my R group? These two carbons. And I have acid catalyst. What do you get? Well, my general reaction says, and Dr. White says, keep your eye on the carbonyl carbon. I will. I'm going to draw that carbon first, which becomes this carbon. What's attached to it is still attached to it. R prime and R double prime. Well, I can do that. Next, I'll have a hydroxyl group because I break the pi bond of the carbonyl group, carbon double bond to oxygen. Then I'm going to have another oxygen on that same carbon. And what's my R group? Whatever carbon is bonded to the hydroxyl group here, oxygen, will be bonded to this oxygen, in this case, it's ethyl group, and I'm done. If this reaction didn't exist, we would never have carbohydrates in the next reaction. So this is important. Well, my book, this is a little tricky. We get into really difficult but doable organic chemistry. This and the next three reactions are probably the most challenging of the semester. So if you don't get it right away, you'll get it. If not, I'm going to try next week, weather permitting, to get here earlier, see me after lab, any lab period, and I'll help you out. All right, let's try another one. Better yet, I'll let you try one. And the question would be, what's the organic product or product for the following? I just want to check if I turned it on. Carbonyl carbon. That's what the fun is. That looks like the last carbon that just stopped going down. I'll give you 3.2 seconds. 0.1, 0.15, 0.2. All right, let's take a look at this. What's different? That's the thing I always do when I look at a molecule. Another way of saying it is, what functional groups am I dealing with? I look here, oxygen, double bond to carbon. Hydrogen, and that could be R prime, in this case it's hydrogen, carbon's here, I'll call that R double. Hydroxyl group on a carbon, alcohol. Acid catalyst. What do I get? Hemi-acetal or hemi-ketal. What's attached to the carbonyl carbon is still attached. You get a hydroxyl group, oxygen, and our from here. So if we look here, what's our prime? This hydrogen. What's our double prime? The methyl group. What's our? My methyl CH3 in the alcohol. And now the easiest way I find to construct the product is keep your eye on your carbonyl carbon, which becomes this carbon. So I'm going to draw that first. What's attached to it is still attached to it. Our prime is a hydrogen. Our double prime is ethyl. Then I'm going to have a hydroxyl group. And then I have my oxygen. And what's our methyl? And I form this product. Oh, before I forget, next Monday, I will be going through the ethers and epoxides problem set, because if my memory serves me correct, this Monday I already went through the alcohols problem set. So I'll do that. Make sure you try it before you come in on Monday, because that will help you do better on test 2, which is coming up soon. All right, let's do one more. Let's have some fun. I'm going to let you loose on this one so you can have fun, but before you do, time out. Oh, 2 functional groups in this molecule. This is a ketone, and it's also got an aromatic ring. Now, let me ask the following question. Does anybody here know reaction of an aromatic ring with an alcohol and acid? Because I don't. So that will never react with that. Do you know a reaction of a ketone and alcohol and acid? Yep, so go ahead and try it. I'll get out of here and pass this way so you can see it. I'm learning names big times, and I have and will keep my promise by test number 2. When I hand it back, I'll know all your faces in first time. Good job. Came in late, the attendance sheet is up here. Yes. It's carbons, it's hydrogen, that's why I put it down. Why don't you wait until I do the problem, okay? And if you're still unsure, ask a question. One thing I haven't said in a while, and I better say it now, remember, it's always true in my class, there's no such thing as a dumb question. Actually, outside the class too, anywhere in my life. And that applies to me too. I ask questions. All right, let's take a look at this. What do we have here? Well, I gave it away. Ketone. What's different? Carbonyl. What's on there? Our prime, but it could have been a hydrogen. It's not. And our double prime. This so happens, the benzene ring, and either one you can call R prime and R double prime, doesn't matter which, but I tend to do it this way. And this is R. It's carbons and hydrogens, and we also established with my help that this is not going to react with that, so this is coming along for the ride. And next, what do we have? Ooh, hydroxy group on a carbon, alcohol. Acid catalyst. What do you get? Right, the carbonyl carbon, which becomes this carbon. What's attached to it? R prime or hydrogen, and R double prime are still there. Keep your eye always on the carbonyl carbon, because that's where the fun is always. And then what do we get? Hydroxyl group, oxygen, and the R from the alcohol. So what am I going to start with? That carbon becomes this carbon. What's attached to it? R prime, methyl. R double prime, benzene ring. Hydroxyl group, oxygen. Which carbon has the hydroxyl group here? The center of 3 carbons. Therefore, the center of 3 carbons, an isopropyl group will be on that oxygen, and that's how you do it. And now we're getting into some really juicy good stuff. I told you I'd be happy in this chapter. Yeah. Now, if you can react a ketone or an aldehyde with 1 molecule or 1 mole of an alcohol or an acid, it turns out you can also react 2 moles of an alcohol with a ketone or aldehyde. In that case, let me go through the reaction. You're going to break the pi bond, and then I'm going to show you something else, but let me do the general overall reaction first. Ketone or aldehyde, when R prime is H, aldehyde. When R prime is carbons, ketone. Not 1, but 2 molecules or moles of alcohol. Remember, the coefficient in front tells you how many moles or molecules you're dealing with. 2 plus acid catalyst. We put H plus, that means you've got enough acid to catalyze whatever you want. And you'll have your carbonyl carbon becomes that carbon. What's ever attached to it is still attached to it. And now, it's a little different than what I just showed you. Both alcohols will add to the carbon that was the carbonyl carbon. Now, I'm going to write underneath a sort of what I'll call quasi-mechanism. Mechanism is where you know what's happening step by step. And part of my training as a synthetic organic chemist, and mainly because of my research advisor, PhD advisor, Dr. Rouge, he was always adamant. Any reaction you ever work with, you should know the mechanism. And he tested us when we were talking, when we give our research every other week. People would present it. He'd make sure you knew your mechanism. And I'm forever grateful to him. And this is not the complete mechanism. When you take this aldehyde and ketone reactor with the first molecule of alcohol, you'll get this, which you've already seen me do. And I could do the step-by-step of this, which most students would find for this class more confusing than helpful. Now, it turns out the second step of acid and alcohol reacts with this. This reacts with this to make water. It leaves. This comes attached loses H plus, and that's how the second OR attacks that, replaces the OH with OR. And that's how you get to this. Remember, the carbon in the alcohol that has the oxygen here will be the carbon in the R group in the ketal or acetal that you get here. Now, this is one of the most important reactions Mother Nature uses, because this is how she makes all the starches in our life, using this reaction. When we get into starches later on, I talk about carbohydrates. We'll come back to this reaction, because this is quite critical if you like starches, which unfortunately I do. All right, let's try it out. And the question would be, what's the product or products for the following? How do you do that? Well, you look and say, what am I dealing with? What's different? Carbon, double bond to oxygen. Carbon's here, carbon's there. Ketone. I'll call this R prime, you can call it R double prime, doesn't matter which you call which. And I'll call the other one R double prime. And then I come up, ooh, number 2, that's unusual. I have 2 of, what is this? Hydroxy group on a carbon, alcohol. Plus acid catalyst, this is my R. What do I get? When you start with an aldehyde, this is called an acetal, and ketals are when you start with a ketone. Turns out most of your starches are polyacetals, and I'll teach you that later on. So what do? Start with the carbon here. That's the carbonyl carbon, which becomes this carbon. What's ever attached to it, R and R prime, stay attached to it. Because you break carbon-carbon single bonds? No. And now I know R prime is ethyl, R double prime methyl. Then I'll have 2 oxygens. And here, what's R methyl? And that's how you do it. Time for a public service announcement from the management B, and that is I highly recommend this weekend, besides finishing the ethers or working on the ethers and epoxide problem set, I can get a head start and start working on some of these. And the question would be, what's the product or products for the following? Remember, these are challenging, and practice makes perfect. Ooh, coming in contractions next week in lab, if my memory serves me right, you'll be putting a nitro group on a benzene ring. All right, let's take a look at this. Let's look at how do you determine what's the product or products that are followed. And what functional group am I dealing with? Oxygen double bond to carbon. In this case, it's got a hydrogen and carbon. It's an aldehyde, but it could have been a ketone, so I'll write it this way. When R prime is hydrogen, aldehyde. Number 2, that's important. And then carbon hydroxyl group on a carbon, alcohol, acid catalyst. What's the general reaction? What's ever attached to the carbonyl carbon will be attached to the carbon here. Then I have 2 oxygens, and each oxygen is bonded to the R group from the alcohol. And now I come up here, I'll call this R prime, R double prime, R, and I'll construct my prime from this before I kill myself. And keep your eye on the carbonyl carbon. That's where the fun happens. You break the pi bond. What's attached to it, R prime, is what? Hydrogen. R double prime is 3 carbons. Then I'll have 2 oxygen. Next, I'll look at the R groups from the alcohol. Which carbon has the hydroxyl group of the 3 carbons? The N1. So each one of these will have 3 carbons. And that's what you get. Now, an interesting reaction that my advisor's advisor, Herbert Stork, Dr. Stork from, I think one of the, I forgot which New York university, was a great organic chemist. If you know synthetic organic chemist, or was, I don't think he's alive anymore, came up with an interesting reaction using this reaction that has been very helpful in synthesis. And how many of you are familiar with raincoats or umbrellas? I think all of you are. And if you want to go from here to your car, and let's say it's spring and it's raining, and you don't want to get wet, or you're coming from your car to here, you'll put on your raincoat or open up your umbrella. Now, once you get into the building, what do? Well, you don't wear it all the time because you don't have to worry about hopefully getting wet in here. It's not going to rain, at least I hope not. And therefore, you put on something that protected you. Well, the same concept is available in organic chemistry. When you have molecules with different functional groups in the same molecule, you're doing a reaction that will attack both functional groups, and you only wanted to attack or react with one, you protect the other one. And what Stork came up with was the following. This reaction, you can take any ketone or aldehyde and react it, and this is ethylene glycol and acid. And this is a way of putting on the protecting group, just like you put on your raincoat. It protects aldehydes and ketones. Well, what's going on? Let's take a look at this. Well, this I already know is an aldehyde and ketone. Let's look at this. What's different? Well, it's got an alcohol. Wait, it's got 2 alcohols. So in reality, this is really this. And what you get would be this. So if we look at, for this example, with any aldehyde group or ketone reacting with ethylene glycol and acid, what would you get? Carbonyl carbon becomes this carbon. What's attached to it? H plus, H or R prime. Sorry about that. And that's it. You'll get the 2 oxygens. But now what's R? that. But do you break carbon-carbon single bonds? No. So this bond is still there. For some reason, students always forget to put that bond there. I don't know why they forget to put that bond there, but they do. Don't, because it's wrong. And you can tell if you forget, that's only got 3 bonds to that carbon, so you know something's wrong. And this, one of the reasons this works well is because the second alcohol is already attached to the ketone or aldehyde when it's reacting. That's called the intramolecular reaction in the same molecule. And that's always a very quick, high-yield one, so that makes this quite attractive because this goes on very quickly, and I'll show you later on how to take it off. And why don't you have fun with this one? Don't get out of your people's way so you can see it. Question, 3 points, give the organic product or products that are following. And again, on these reactions, I'm just going over, I will never put a synthesis. At my level, yes. At your level, not yet. Never, actually. Oh, an update on the video this morning at 7. I was working with some people here at the school on the phone from my home, trying to get me able to upload, and they're still working on why I'm having a problem, which I shouldn't, but I'll still be this weekend uploading to YouTube. Anybody have a chance to look at it of those? If not, this weekend, if you have a chance, I will too. Look at it and tell me what you think.
What is it called again?
What?
What is the YouTube?
All right, go to, if you just go to Google and put in the course name, CHEMI 1212, put in my last name, White, it will take you right to the different ones. I tried, and I don't know why it wasn't working, it's DRK White 77. But just do, even Google, just put CHEMI 1212 White, it will take you. And check. All right, let's go ahead and do this. And the question is, what's the organic product or product we're following? What's different? Ooh, carbon don't bond to oxygen. I'm happy. Carbonyl group. Carbon's here. R prime. Carbon's here. R double prime. This could have been hydrogen. It's not. It's a ketone. And, ooh, carbon with hydroxyl alcohol. Second carbon hydroxyl alcohol. And you know this general reaction with acid catalyst. Put the carbonyl carbon, which becomes this carbon, what's attached to it, R prime or hydrogen, R double prime, then has 2 oxygens, and the R group from the alcohol. So what's R prime? Methyl. What's R double prime? Methyl. This carbon right here becomes this carbon. I'm going to write it first. What's attached to it? R prime, methyl, R double prime, methyl is still attached to it because do you break carbon-carbon single bonds? No. Now I'm going to have my 2 oxygens, and then what's R? But don't forget the bond there. R is CH2. But you don't break the bond here. Again, for some reason, students forget to put that. I have no idea why, but don't forget to put that bond there. And there you are. And this is a really neat way of protecting ketones and aldehydes when you're doing a reaction that would react when you don't want to react with them. Now that you have this, what can you do with it? Well, you can react it with acid and water. And guess what? It takes you back to the original alcohol and ketone or aldehyde you started with to make, in this case, the hemiacetal or hemiketal. Got a question for you people. Where can I find real quick in this classroom acid and water? Anybody know? Where I can find real quick right now in this classroom acid and water?
Stomach.
Your stomach. My stomach has acid, hydrochloric acid, and it has water in there. I've been drinking water today and it's going somewhere, hopefully my stomach, eventually. And think about it. Your stomach is a walking chemical reactor. You're a chemical plant, mobile chemical plant, really organic chemical. And this reaction and the next one are reactions your body uses to break down carbohydrates to provide nutrition to you. And when we get into carbohydrates, I'll show you the specific reaction. So if you're asking, why am I learning this really hard reaction? Well, it's going on in your body right now if you've consumed any carbohydrates for the last whatever time period. So if I take a hemiacetal or hemiketal, our prime can be either carbons or hydrogens, react it with acid and water. I usually put this, and most organic chemists will do it on top or below the arrow. What you'll get back, this decomposed, breaks back down to the original aldehyde or ketone you would have used to make this that I just showed you, plus the alcohol you would have used to make this. And therefore, if I do the following, and ask what's the general reaction, or what's the product or products are following, how do you do that? You look at what's different. Now, here's a giveaway for acetals, ketals, hemiacetals, hemiketals. This is the only place I know where you're going to have one carbon with two oxygens bonded to it. It's rare, it's special, it goes on in your stomach, and we'll learn how this happens in sugars and carbohydrates, but let's look at this. What's different? Carbon with two oxygens. One is a hydroxyl in this case, one's R, alkyl group carbons. Then to the same carbon, what's different, I have a hydrogen, which I can also call R prime. It can be carbons. And I have carbons here, which I'll call R double prime. What do I get? Keep your eye on the carbon with the two oxygens. This carbon becomes my carbonyl carbon of the ketone or aldehyde. What's attached to it in terms of carbons or hydrogens is still attached to it. What's R prime? Hydrogen. What's R double prime? Methyl. Next, I'm going to get my alcohol. The carbon with the oxygen here will be the carbon with the hydroxyl group here. In this case, the N carbon of 3 carbons. And we do this. You guys see this okay? No? Just checking. You see? And that's how you do it. And again, this reaction is one of those, I'll never put a synthesis. Now you got to keep your eye on what's different. Question B, what's the organic product or products for the following? Alright, you walk slowly to the board. One step, two steps, like in life, one step forward. That's true, sometimes they happen. All right, let's go ahead and do this. And question is, what's the organic product or products that are followed? What's different? Who carbon with two oxygens on it? One has a hydrogen, the other has alkyl group or carbons, and this is a hemiacetal or a hemiketal. It's got carbons and carbons. I can call it R prime, R double prime. The R prime could be hydrogen, but it's not. And I'm reacting with water and acid. And what happens? You get back the aldehyde or ketone you would have used to make that. Keep your eye on the carbon here with two oxygens becomes this one. The carbons on that oxygen becomes the alcohol you would have used to make that hemiacetal or hemiketal. This I can call R prime or R double prime, doesn't matter which you call. This I'll call R double prime. My carbon on the, in this case 1, on the oxygen I'll call R. And now constructed. Since I love ketones and aldehydes, I'm going to go with that first. You can do the alcohol first, but I know. This carbon becomes this carbon. What's attached to it is still attached to it. What's R prime? 3 carbons. What's attached there? R double prime, 2 carbons. Double bond to oxygen, my ketone. My alcohol, R, 1 carbon, and that's it. And again, this is going on in your stomach, not with these molecules that I have here, but other ones more complex, which later in the semester I will teach you about. Next time you eat, remember when it goes into your stomach and your small intestine, it's being broken down by organic chemical reactions. You're a walking chemical plant. Now, just like you can add acid and water to an hemiacetal or hemiketal, you can do the same thing with an acetal or ketal. And this turns out to be the first step that goes on in your stomach when your stomach is breaking down carbohydrates, starches that you consume. And here we have an acetal or ketal reacted with water, which is in your body, acid. I always think of a miracle that I have in my stomach and you have in yours, cells that manufacture, synthesize hydrochloric acid, which is the acid in your stomach. And what happens is keep your eye on the carbon, look for something different. A carbon with 2 oxygens, there's only 2 places in all of organic chemistry that I know this happens. Hemiacetal or hemiketal or ketal acetal, which is this. What you get back is the ketone or aldehyde you would have used to make that, plus the alcohol you would have used to make that. And this is the general reaction. And if I look at the clock, I'm going to let you out a whole 65 seconds early. With that, I will see those of you who don't have lab.